A wonderful good afternoon, dear LinkedIn community and Composites experts out there. Thanks for joining our live show that is powered by the Composites Launch, a LinkedIn group here in the German speaking countries, Germany, Austria, and Switzerland. So this time we will be speaking in English because I have a special guest here, and this is Max Schultes from RAMPF Technologies, RAMPF Holding, RAMPF Composites, the Composites CTO. Welcome to my show, dear Max.
Well, thank you very much, and welcome everybody from wherever you're joining. Good afternoon, good evening, good morning. Well, we're glad to have you here, and excited to talk about our technologies and how we can enable your revolutionary ideas and concepts and move the needle significantly forward on the progress side.
Wonderful. A bit of a housekeeping. So this is a LinkedIn live format. And what I love from this format a lot is it is very interactive. So you have below this LinkedIn live stream the possibility to network among each other. You can ask us questions or put also in some comments. And we will be checking regularly your comments on this live stream. For the beginning, for the starters, just write into the chat from where you are tuning in. Can you hear us and see us in a good way? Because this is a live stream, always can be technical hiccups here, and we want to make sure that you hear and see us in a most best way that is possible here on LinkedIn. For you, just as a background information, Max is right now in Canada. He is in a different time zone. We are 6 hours apart. So we have now in Europe 5 p.m. is how do we call it in CET? Yeah, CET, yeah. Central European time, and Max is in the Eastern time. So we have a time delay here from approximately 10 to 20 seconds. This is not because of our distance, because Max is actually closer to the StreamYard server than I am, because the server is in the United States. Today's topic is about composites, and I came across Max in our Composites Launch group. And one of the things that really attracted me and caught my mind is that they are, having mastered the art of product development in the composites sector. For a starter, however, before we delve into product development and what great and fantastic solutions you are offering right now, Max, can you shortly describe us what RAMPF Holding is doing? Where is it coming from? What is the mission? And what is your role within that mission?
Yeah, so the RAMPF group, many in the composites community might know us from the tooling board side, from tooling materials, the board materials, close contact casting, or the paste materials. That's what in the composites world the name RAMPF is really traditionally linked to. And RAMPF is the world's largest tooling board manufacturer, but we are usually pretty quiet about it. And over the 42-year history of the company so far, we've expanded into a couple different business areas. So we have 6 different core competencies in total. Tooling being one of them, like the board materials that you can, or the casting materials that you can use for fixtures, for direct tools, for patterns, for bonding fixtures, trim fixtures, etc. We also have liquid reactive resin systems for tooling manufacturing, but also for parts manufacturing, for instance, epoxy-based, urethane-based, gasketing materials that are silicone-based, for instance. We have a sister company that is working on automation. So high precision meter mixing and dosing equipment, and the whole robotics and automation around it. That's heavily used in the automotive sector, but also in other industries as well. And in that case, for instance, you can buy the chemicals from us for the sealing, gasketing, for electrocasting, for bonding, whatever it may need. And you also can get the automation and the application robotics behind it from us. We have another company not really linked to composites in the sense that we're talking about it here today, that's working with mineral casting for casting machine beds out of a polymer and aggregate mix. The advantage that's used for large machine beds, large and small machine beds, and for CNC machines, for additive printing machines. etc. The advantage there is, with it being a cold casting process, we can already implement sensors, we can implement wiring, we can implement conduit right into the casting itself. With working with the polymer and the aggregate, we can influence the different vibration and dampening characteristic a lot better than in a cast iron, for instance. And you get, it being a cold casting process, a lot higher accuracy. So straight out of the mold, you get accuracies between 1 and 10 microns, for instance. But again, we're not really talking about mineral casting here. We are more in the composite sides interested. So we do have a company linked to the tooling industry, where for the last 25 years, we have worked on the recycling process of tooling materials. Like I said, we are the world's largest tooling board manufacturer. So naturally, there's a lot of chips that are being created in that in that process, and also with our customers. So we've developed a chemical process for taking the chips, reclaiming them, recycling them, and then feeding the polyols back into our production. And it's not something we've just started yesterday. Like I said, we've done that for the last about 25 years. We do that for our own production, but we also offer that as a service to our customers, to help them set up their recycling plant locally or in a cluster of companies where it makes sense to cut down on transportation, etc. And then last but not least, the company that I'm spending most of my time with here in Canada is RAMPF Composite Solutions, where we design, develop, and manufacture composite components, mainly for the aerospace and defense sector.
Wonderful. That is predestined for the Canadian market. So let me shortly greet our community. We got here today Carsten from Oberhausen, then Gerd Samland from Hamburg, North Germany, then Oliver, one of the co-founders of the Composites launch. Nice that you have found the time, Oliver. Carsten Brauer from Nordsaxon. Okay, wonderful. The east of Germany is also there. Greetings from Istanbul, from Inji. Greetings back to Istanbul right now. Nasri is from Herrenberg, South Germany. Wonderful. And then we got Joachim Hennig. He's also a legend in the composite industry for many, many years. And he says hello from this wonderful city of Hamburg. And that's very, very good that you are really joining us for this live. Max, the first question I'm having to you is, now we've known that you are multifaceted and of so many different solutions. So in my view, you are like a one-stop shop for composites. Even if you probably are not in every single kind of manufacturing process, but you have a very wide range of processes. Now, we have a situation right now which is a bit challenging on a global scale, not only in Europe, but also, of course, in your continent and throughout the world. We want to, for obvious reasons, become a little more electrified. We want to reduce CO2 emissions. That was the first one. But now we want to also be more independent from oil-based derivatives, from fuels that are derived from, oil. Electrification is one thing, and now speaking about the aviation industry, we have a very long standing tradition in the aerospace industry that takes years, maybe even decades, to change and develop solutions for the aerospace. I myself, if I check just for one of my last assignments, for example, the specifications of the seating cover fabrics, textiles. And I've seen that most specifications in the aerospace regarding textiles are somewhat from the 1980s. Yeah. And so it's a very, very long span with the specification that lead into airworthiness and all the regulations in the aerospace. Now, with all these approaches these days and all these requirements, we need to act much, much faster. How can you help, or let's say, what else do you see as a problem right there in for example, the new mobility, like the air taxis, the volocopters of this world? Where do you see those problems in the development, and how would you approach, from a composites manufacturer's point of view, such a challenge?
Yeah, so like you said, there has been over the last decades, there has been a steady progress, but a steady and relatively slow progress. So what we've seen over the last couple of decades was really smaller incremental steps. And like you said, the developments if we talk about traditional aerospace, can take very long time. And the durations can be very long. And also the progress that we do is just step by step, little by little. If we look at the challenges that we have ahead of us from a emission standpoint, from a propulsion standpoint, from an efficiency standpoint, and we look at the goals like Fit for 55 or Airbus putting out a hydrogen powered aircraft by planning for putting it out by 2035, I think it becomes quite obvious, even just looking at the traditional side of the aviation sector, that the small incremental steps, while we still need to maintain them and improve on them, what we really need is we really need to enable bigger, larger steps, more revolutionary developments rather than the small evolutionary and incremental steps to reach those goals and also to reach sustainability in a whole. Now, what has been a hindrance traditionally, if you look at the typical development process, has been that on a schedule perspective, the first time we really start testing a component in a sort of a system level configuration is in the so-called verification validation phase. That's the first time in the development progress where we usually start testing something where we can really see the performance of it. Anything before that is heavily design based, and that's important. Don't get me wrong. That's the world I'm coming from, but it's heavily theoretically based and based on past experiences, the previous generation, and also on the material side on like coupon level testing, because there is the typical building block approach that we work up on the system level, and that's often because to create tooling, to create the components, you have to invest quite a bit of money, and it's usually because of the processing characteristics of the materials involved that you wait until a certain maturity in your concept, in your development, that you start committing to the tool because of the long lead times and because of the high cost. In order to really make the revolutionary developments possible, I think we need to move the timeline for testing much further to the left. We need to really start testing a lot earlier in the progress. So we need to enable the sort of system level, a prototype level testing much earlier in the process so that we do allow in our development schedules for an iteration and a modification, and that we don't completely blow out the schedule and completely blow out the budget if we have to do a not insignificant redesign after our first test. Now, how do we achieve that? We can talk about that and how we've developed solutions of how we can achieve that. We can talk about that later. But that also explains of why in the past we've only seen those small incremental steps. Don't get me wrong, with small incremental steps, you can make huge progress. Just think about the jet engines from 30, 40 years ago and the black smoke trails behind them and the noise levels, and you compare them to the high bypass ratio turbofans of today. So there is a lot of progress that can be achieved by it. But looking at the traditional aerospace sector and then looking at you mentioned the whole urban air mobility or advanced air mobility. So let's include the electrification of regional aircraft, for instance, into that as well. Is those timelines that are put out there are quite aggressive. And in my opinion, we cannot achieve those timelines if we just continue on the traditional path. So if we talk about why has it been slow, safety is one aspect, and we don't want to compromise on safety at all. We still want to improve the safety of the entire system and ecosystem, but then budget and schedules are the two variables we can play with. Variables is a little bit relative because I can't see budget pressures going away anytime soon, as well as schedules. We don't have that much time left to reach the goals that we need to reach and that we need to achieve. So we need to be able to really test early on and make that testing early on affordable for everybody involved.
That's right. Security is first or safety is the first priority in the planes. Still, we have these very long lead times, and I'm really curious to know what types of solutions you can come up with. But before we continue, Max, I have a surprise guest for you and for our community.
Okay.
I've invited Eric Pierjean from JEC Global, the CEO, to join us on this LinkedIn Live session, because one of the things we want to promote and talk about, of course, is the preparation for JEC World. RAMPF will be on JEC World in Hall 5. So, and we want to make sure, of course, that you also will be passing by the RAMPF booth. So, Eric, hi, thanks for coming and following my invitation as a surprise guest here on this LinkedIn Live show. Yeah, how are you doing right now? Easter eggs? Have you collected Easter eggs in Paris?
Hello, Max. Hello, Ilkay. Yes, we have collected many eggs, and we are very excited to welcome the whole Composites community in Paris very soon, finally, because we all have been very patient. We had ups and downs, and now I think we're ready to welcome you. Weather is great. I hope it will stay like that, and of course we are welcoming all our exhibitors, and especially RAMPF. I know, Max, you have very interesting products to present, very upstream with resins, but also with some applications, especially in the aerospace industry. I don't want to disclose any information, but I think it's already something you communicated about. Yes, aerospace applications.
Yeah,
wonderful.
There's no secrets.
Yeah, Eric. So this time, one of the questions I want to ask you is, the Innovation Awards next week are on the 26th of April. Why did you decide to have the Innovations Award not on the Paris show floor, but on a separate event? Can you walk us through your decision making on this one? What is the benefit, and why did you do that?
Well, in fact, we will have them on the show floor because, of course, we will present them at the show. But we wanted to communicate earlier on the awards, to present the finalists, but also the winners, so that we make sure that before the show there is a stronger communication and invitation to discover the awards finalists and the winners on the show. We were doing it during the show in the past, but I think it's a better way, and I hope it's a better way to have press coverage and to have much more awareness and visibility before the show, and invite people to come to the show to see them. You know, so it's a matter of efficiency and communication impact.
Okay, that makes, of course, total sense. If you look at the communication, that the participants and the candidates have been selected, nominated, and then the award ceremony has been conducted, that the show can focus, of course, on the PR and the marketing and the solution side. So it makes total sense to me. Now I understand. Thank you so much. What new aspects do you bring up on JEC World 2022? Because I would assume that the initial one that was scheduled for 2020, now we are 2 years further, you may have changed a few things. What did you change from the 2020 intentions to this year's show?
Well, you know, the intentions are always the same. I would say it's to bring together the community and also to be a showcase of what the composite industry has been creating in terms of innovation. And I must say that innovation, and Max knows it very well, has not stopped during the pandemic. All companies have constantly innovated in materials, in applications. And I think after this forced break without a show, it will be a wonderful festival of what the composite industry has been produced. And that, you know, there are many major changes and challenges for the industry with new mobility, with new fuel. You mentioned hydrogen. There are many sectors where the innovation has gone very fast. So I think the best promise will be that after so many months and years of interruption, we will be able to present the whole palette of what the composite industry is doing.
Very good, very good. So we are all excited to be on board. Let me get from Max a live testimonial for you, Eric. Max, how is the process with JEC Global going on, the organization?
We've been there for a number of years, and we've never had any issues. We are really excited to be back. It's been a long forced break, and yeah, we are excited to reconnect. For us in the composites world, the industry in the composites industry and sector, the JEC World is the most important trade show for us, and it's good to be back, and we're excited to be in Paris. And I hope the good weather will last, and I promise to not bring the snow that we got here yesterday, and I'll leave that in Canada. So.
Please no.
At least the likelihood, Eric, now being in May rather than in March, is much higher that we will have a lot of sun in France, of course, and have lovely evenings with some, Bordeaux wine in the evenings. So that would be, of course, the higher probability now.
That sounds like a plan, Ilkay, from you. Huh?
Yes, absolutely.
But I think it's we are all very excited. I think all exhibitors, participants, we can see it on social networks. We see it with the contacts we have with our customers. I mean, it's really a great moment, which has been long. We waited for it for a long time, and we all were ready and excited to meet again.
Absolutely. Thank you so much, Eric. Thanks for stopping by.
Thank you.
I think I will continue now with Max on the applications and on our markets. And we see us all in May in Paris. And then we have the time to discuss much, much more in length. Thank you so much, Eric, for joining.
Thank you. And see you soon.
Thank you.
Okay, bye-bye. So, Max. Okay, so let's come back to your initial thoughts about the aerospace industry, that it's making very slow progress. Now, you mentioned to me we have some constraints here: safety, budget, and of course schedules. So, what is the process, the workflow that you are applying in order, to address these constraints in future? How can you help customers that are with their components R&D, with their development, with their designs, always in these constraints, in this triangle of safety, budget, and schedule?
Yeah, so we, as being a company, like I said, you can look at RAMPF as a one-stop shop from the tooling material all the way to the finished product, but we also do everything in between. And as coming from the composites manufacturing side, from the development and manufacturing side, we were faced with that situation as well. When you look at the usual suspects in the structural composite components for aerospace, you have to put quite a bit of investment into the tooling. You have long lead times for certain tools, and you also require quite a bit of infrastructure. If you look about the usual suspects from the on the RTM side, for instance, you need to have your material at 80 to 90 degrees Celsius. You need heated lines, heated hoppers. You need a tool that runs at about 100 degrees Celsius, and then you still have quite a long cure time. And so this was one of the obstacles that we saw in how can we move the prototype testing much earlier in the process? How can we enable proof of concept testing without having to use a substitute on the material? We want to be able to use the final material to really have a true assessment of the performance. So yeah, sure, we could go to a cold curing standard epoxy resin, but that doesn't really give us a good answer on what is the final performance of the part in the final configuration. So we were faced with that situation. many times working with our customers on developments, and so we said, hey, we have some pretty smart chemists in our company. Let's talk to them, and we just, maybe in a sense naively or optimistically, gave them data sheets of very established systems that have been around and accepted in the sector for a long time, and said, hey, here's those two systems. Can you formulate a system for us, or a family of systems for us that meets or exceeds these performance values? So a high TG, a high toughness, good structural performance, good fracture toughness, for instance. But we want that system in nice. We want to be able to actually manufacture components on prototype tools. So we want to be able to take some of our tooling board or a close counter casting shell that we can get very quickly and very affordable, and machine a direct tool and then manufacture a part on it. So can you do that for us? Can you formulate something for that? And but the second part, or the other side of that coin, is not just prototype tooling capability, we also want rate capability. So if you look at the standard RTM system in the sector, it needs about 6 to 8 hours in the press for curing at high temperatures. So there's the limit of how far you can scale until you have to invest a lot more money into more presses and more equipment. So we said we want to be able to produce some prototype tooling to enable this early stage prototype development, concept verification and validation, but we want it to be fully rate scalable so that we cover that whole aspect. And so the target there was we want to be able to cure it within 2 hours. So it took our chemists a while, but they came back with a family of systems that we have now. 2 of them we've already qualified on OEM platforms in the commercial aerospace sector. And the third one is also in progress. That's more on the interior side. But they came back with those systems which cover that, which really bridge that gap from very early prototype to a full rate scalability. And I said we gave them the target of 2 hours for the full cure. They actually beat it, and you can cure it within 1 hour. So once you are through your qualification and your initial low rate production, which you can still do on a prototype tool, those tools will last tens to hundreds of cycles, depending on how you treat them and what the complexity of the component is. You can do your initial low rate production while you then invest into your very well-known, established, high-rate manufacturing, traditional tooling approaches. And that's when you can achieve those high rates. I mean, being able to pop out a part within an hour is, in my view, a rate scalability that does suffice for the majority of the aerospace applications. I mean, we're not talking about little clips and brackets. We're talking about structural components, larger parts, everything maybe between this to a wing structure. I think you're on mute, Ilkay.
Correct. So how does this relate to your tooling department? The bullet point here is the closed contour tooling. First of all, can you explain us what is a closed contour tooling before we dive into it? Because some of our viewers may be just users, and they may want to understand what this tool is and how do you compare or contrast it with other tools?
Yeah, so most of you will probably be familiar with the tooling board. So you can buy the board in different sizes, different thicknesses. You'll stack it up, you'll glue it together, and then you'll machine it down to your shape for your pattern or for your direct tool. The other option that we also have been offering, I think for about 20 years or more now, is the same materials. So epoxy or urethane-based materials, we can create what we call a closed counter casting. So instead of stacking up all these blocks, like basically playing Lego with the tooling boards, what we can do is we can create a shell for you. So you send us the CAD model, and we create a about 60 millimeter thick shell with a backing structure and ribs, etc., already cast right into it. And this shell is slightly oversized. So you can get this shell. Our standard service time is 15 business days from initiation of order or from when you send us the CAD file. That's when you get this shell. So this shell is slightly oversized, maybe like 20 millimeters, 25 millimeters oversized. And you just have to machine away that little bit of excess material, which helps you a lot on the machine time, cuts down the machine time. You don't have to do the glue ups, and you have a completely seamless shell, which you then can use as a master pattern, or using our resin systems that I just talked about, use it as a direct tool where you can then start directly manufacturing on it. So like I said, standard service times are about 15 business days, and you need a few days for machining it. So you can really start building your parts within a couple of weeks, within a matter of weeks, rather than having to wait sometimes months, like 4 to 6 months for certain larger tools, and invest a lot more money into those LTM tools or aluminum tools or these large scale tools. So you can have your tool in your facility at a very quick turnaround time at a very affordable cost, and then you can start manufacturing your prototypes. Size-wise, there is basically no limitation to this process. We should still get it out of the door, and we should be able to ship it. But yeah, you can create wing size shells, you can create fuselage size shells in one go that you then can use as a tool. Because logistics may be a question there, we do have this offering both in Germany for the European market as well as Asian market, and we have 2 centers in the US to serve the North American and South American market as well.
Okay, I'm using your presentation right now.
Yeah.
And there is a slide that is RAMPF Tooling Solutions. If you don't mind, I would like to show it.
Yeah, of course, go ahead.
Yeah.
Yeah, so here you see the board material, right? On the top there, you see the stack up of this concept car structure, and then at the bottom you see how it's already partially machined. So you can imagine there is quite a bit of effort into the stacking up. But for some sizes, for certain applications, it may be the more efficient way to go and the better way to go. If you advance it, that's a close contour casting. So you see the same car, but you can see it a bit there is on the top. It's it's finished the casting process. The backside mold blocks have already been removed. And then at the bottom, you see the shell. On the left side, it's already machined. On the right side, you see the sort of the skin as it comes out of the mold. So the mold for this is a very low cost, just EPS mold, so styrofoam mold. It has that gets a silicone coating. That's why you get that shiny skin on it. And it's something we can very quickly manufacture and then cast the shell for you. And like you say, it's about a 60 millimeter thick shell, which makes it quite nice for handling and for weight, from a weight perspective, etc. So you don't need heavy equipment to move it around. And then last but not least, what you may also know from our tooling products is the close contour pastes, where it's used a lot in these styling applications. You also see it heavily used in the marine industry or the wind energy industry for the wind turbine blades. You build up a substructure that can be a wood structure, it can be a styrofoam structure, or a lower density foam, which is undersized. And then you apply the paste, again, like between 30 to 60 millimeters thick, which then creates an oversized component, and then it gets machined down to the final shape. Like you see it used heavily used in concept cars, but like I said, also for very large structures like wind turbine blades, marine structures, etc.
So give me an idea about the cost of such a tooling that we see here in the column.
I'm coming from the composites manufacturing side, so I actually have to apologize and pass.
Okay, that's the colleagues from the tooling, of course. Yeah.
From the tooling side, think about it as it is a completely volumetric pricing, right? Mm-hmm. So the material has a certain cost per liter. I'm very happy to put you in touch with my tooling colleagues in Germany. Unfortunately, my colleague was unable to join tonight here, but he would have an answer, but I'll be very happy to put him in touch with you. I can assure you it is much cheaper than an LTM prepreg tool or an Invar tool or an aluminum tool.
Okay, that's sufficient to know. And we would like to, of course, conduct a follow-up show with, is it Alexander Egge, who is
Yeah.
responsible for that, right?
I think we can give you an answer to that on the at the JEC. I'll make
Of
sure
course,
that you get
yes,
the answers ready.
If we don't do it in live here on LinkedIn,
Yeah.
then we do it at least, of course, on the show floor in Paris. So let's talk about TFP. What is TFP, and what is the benefit of looking into TFP more closely these days?
Yeah, so I mean, we started this whole thing under looking, okay, how can we improve our current status quo? How can we achieve or unlock the potential of composites? And I think we've already shown with the resins and with the tooling, we can really move the development scale or the development to the early on part of the development, and enable you to really test it. So let's talk about sustainability. What you see here is just the definition from the English dictionary, because sustainability it's a pretty heavily used word at the moment. So it is a property of being environmentally sustainable to the degree to which a process or an enterprise is able to be maintained or continued while avoiding the long-term depletion of natural resources. So what does that mean for us as an industry in composites and aerospace is we've got a pretty steep road ahead of us. There's a lot that we have to improve. And when we talk about sustainability, the next word that's often used is recycling. Recycling is something that it doesn't really matter if it's thermoset or thermoplastic. There is no good recycling solution out there right now. And let me qualify that before I get anybody upset about the recycling statement, because if you look at the recycling definition itself, you need to extend the life cycle of the material by a couple of weeks to a couple of decades. So let's say you build a fuselage for an aircraft, you grind it up and you reuse it in a thermoplastic compound for making a tennis racket, a bike frame, a park bench. Yes, that meets the definition of recycling, but it does not mean it's a sustainable recycling in the true sense of it, because it is just a downward spiral of the performance of the material. You just lower the performance level of the material with each step, and in some cases pretty drastically, from an aircraft down to a tennis racket or a parking bench. So it does not prevent the depletion of long-term of the natural resources. So what does that mean? We need to be as efficient as possible with our materials. And looking at the attendance, there is a lot of people that I recognize from the composites industry. I'm sure there is a lot of familiarity with the heavy anisotropic properties of the composites, and a lot of us are probably cringing every time they hear the term a quasi-isotropic laminate. There is applications for it, there is use for it, but there is also a great potential in the fibers, in the material properties that we don't necessarily unlock with the traditional use most composites are used to today. So tailored fiber placement is one of the technologies where you may or may not be familiar with, but this really, on the scale where it's applicable and the scale where it makes sense, does unlock the true potential of the fiber. So what I also, if you click through it, I think there's a couple of points should show up. What I sometimes refer to this is 3D printing for grown-ups. Like, this is really 3D printing on steroids, where you can now really design a fully 3D optimized fiber architecture, and you can create that preform that reflects that. If you have a complex shape and you work with traditional fabrics and tapes, you're kind of limited of how you can optimize it because of how it drapes and how you can actually place the fibers on there. With this, you are in the driver's seat of the fiber orientation. So what is it? It's a highly efficient and scalable industrial process. It's based on industrial embroidery on like every textile that we are wearing. So you can imagine the numbers that are produced there. And we're able to also improve the reliability and quality to an aerospace level. There is a lot of expertise that goes into the design optimization. And at RAMPF, we've brought this technology in-house coming up about 10 years ago. Because we had a development of it's a funny product. It's an aircraft toilet for a commercial aerospace sector, where being a tier 2 in this case, being a supplier to one of the big tier 1s, you're at the end of the food chain cost-wise and weight budget-wise. So they told us, like, here's the product, here's what it, like, here's your constraints, here's what it needs to do, here's how much weight you have, and here's how much it can cost. So looking at the traditional fabrics and tapes, we said there is no way we can make this equation work, both on the weight and the cost side. So I remember this from lectures back in Stuttgart in the university, from my university days, and said, hey, we need to take a look at this one because this might really help us. So we brought the technology in-house. We had quite the learning curve on how to efficiently design with it, because there is no Abacus or Nastran or ANSYS standard TFP module where you say click solve. So we had to implement quite a few things there internally and develop that know-how. But yes, we've done it, and we have this component for, I think, six or 7 years now, is standard line fit on the Airbus A320. So every 320 coming out of one of the 4 manufacturing sites of FELS of Airbus has these toilets manufactured or built into them. Now, this is an example where, like, a small company in Canada developed a solution, developed a process, even developed together with our chemists, we developed a resin to be FST compliant, work with the infusion, and we were able to put that onto a flying platform on a line fit situation within 1 year. So it might be a funny example, it's a toilet, etc., but it is pretty light. Some of you may have seen it at past trade shows or not, but the whole thing weighs 600 grams, like the actual composite structure. But it does, the most critical load case was actually 600 pounds on a very unfortunate position from a geometrical and structural perspective. So you can really unlock the potential of this material with this technology, and if you phrase the conversation right, and if you talk to the right people on both your customer and the end customer and the certifying agencies, you can get these pretty revolutionary concepts through and into the market as well. So what you see here is basically just an example of what a typical cumulative cash flow curve over the life of an aerospace program looks like, or hopefully looks like. So as you start the program, you have to invest money into the development. You have to invest a little further. You have to start testing, you have to start tooling up. That's where you see the steep kink. Then you start manufacturing at the bottom of the curve. And then as you start delivering, you start seeing money coming back. And then hopefully you'll get into the green. And then as it levels off, as just volumes at the end of the life of the program start reducing, and then you have like an in-service support. So this is very typical. There's obviously variations wherever from program to program. But overall, this should look somewhat similar to this. All the development, all the testing is happening very, very early on in this overall life cycle, but it's happening in the cash flow negative portion there. And that's where I think with our solutions that we can offer you, either you're just interested in the tooling, just interested in the resin, or the whole package, or just some development help on the composite side, where we can help you stay above that curve at all times throughout the program, and hopefully make that curve a lot steeper.
That curve is very impressive, and I liked it so much that my clicker mouse, maybe you've heard it, fell down, and that was the noise that I had while you were speaking.
Yeah.
But let's get a little more concrete, Max. I had the other day George Bai in my LinkedIn live show. George makes electric planes like these.
Yep.
I don't know whether you know George Bai's boutique company, but I have a friend, Norbert. Shout out to Norbert right now. He's in Berlin. It's a startup, and he is heavily into the electrification of planes for the taxis. So that will be coming up in the future in Germany soon. If George Bai or any other plane manufacturer approaches you with such a animated Fluggerät airplane, how would you start the discussion? How do these discussions start when developing parts for them? I'm asking because I was asking George Bai, of course, as a composites nerd. George, what type of composites are built into this plane, or are you planning to build in? Is it thermoset? Is it thermoplastic? Is it aluminum? Is it titan? He said, okay, which part are we talking about? Yeah. So how do you approach your customer, to get the best balance in, what was it? Safety, budget, and schedule.
Yeah. The earlier we get involved in a discussion, the better. Take the TFP for example, right? It's not a solution for everything. We're not going to start stitching a fuselage for an aircraft for George Bai, for instance. That's not the application where this makes sense. Like this makes sense on a scale from everything that fits in your hand to maybe the size of the desk, right? You don't want to make floorboards out of it. Where it makes sense is where you have a highly complex structure that has a very unique loading characteristic where you need that, where you have that optimization potential, or maybe you use your floorboard or your fuselage or your wing, but you have some localized load introductions from control surfaces, etc., or a seat belt or a cargo mount where we can then very efficiently put a reinforcement around that load introduction to make the load distribution very efficiently and a lot lighter than just stacking brute force approach and stacking, doing a quasi-isotropic stack up around it. That's where something like this makes sense. But you can only get into these, or you can really only unlock the full potential of your overall solution and optimize for your overall solution if you get involved relatively early. If you're just being approached by, hey, I need this overhead bin, I need this armrest, your optimization potentials are quite limited. So the earlier in a conceptual phase that we get involved, the better of a solution, the better of an outcome, or the more optimized solution I think we can offer. We're technology agnostic. What drives me is finding the best solution for the application, not just using something. Oh, we've got solution ABC on the shelf that's easy for us. That's what we can do and offer. We want to give you the best solution for your product and for your solution and for your problem that you're trying to solve. We may not have the answer, but then we will refer you to somebody else, or we work together with you to get there. One thing that might be interesting for situations like this as well is we can help you. We don't have to make the part. Like what we've done in some cases is we developed it, we did the qualification, and then we helped the customer train their personnel or their supplier, and then transitioned that production or manufacturing to their location for either a dual source situation, for increased supply chain security and safety, or for additional capacity to make sure that the schedules on the delivery side are maintained, the training, etc., so that we are still good on the safety side and that we meet the qualification requirements that were set out there. But all in all, the earlier the conversation starts in the concept, the better it is. We do certainly see in a lot of these conversations, when we do present this package, like tooling, early testing, and full optimization on the full part, that's where people get excited, where say, hey, now I can have a tool for $1,000 or $2,000 or euros in my hand, and I have that within a month or less than that, rather than having to wait 6 months and spending $50,000, $100,000 on my tool. And that gets people really excited.
Yeah. So you have even formed a call to action. So in social media, we talk about CTAs, call to action. So you say enable maximum sustainability. So anything you do, as always, to do with sustainability, let's develop your revolutionary new products quickly and scale fast with our new composite materials and engineering technologies. I think that is a great conclusion of our session of today. You will be speaking to Max at the JEC World. Your speaker is, so now go to the next page, is Max Schultes. He's the Chief Technology Officer of RAMPF Composite Solutions. We thank you for tuning in, everyone. And thank you so much, dear Max, for being part of our show. That was, powered by Composites launch. That's where we are active in exchanging technologies, innovations in the German-speaking markets. Is there anything you would like to add, Max? How can people reach you? Now I've shown the telephone number even, so that will be spread all around LinkedIn, and I hope your phone will be rang by many, many end users that are watching this live. Anything you would like to add as a last part of our interview?
Yeah, throughout, I hope that we could convey. Well, first of all, thank you for having me and for your interest, obviously, to the viewers. I hope we could in this short time frame present of how we can really help you unlock your great ideas and bring those great ideas to market and help reach our goals for the future, for a sustainable future. RAMPF is a company that has always had the sustainability it's one of their guiding principles. So speaking of the recycling that we started 30 years ago, and we want to provide you with the best solution for your problem. And like the slide that you're showing there right now, this is really, we can unlock your full potential. Let's work together. Reach out to me via email, via phone, through LinkedIn. I'll be at the JEC in Paris in just 2 weeks from now, and I'm looking forward to meeting everyone that is interested or that wants to have a chat. We won't have the toilet with us for the exhibit, but we have a few other interesting exhibition pieces, and that really showcase the level of complexity that you can achieve with these materials and these processes. And the performance that it can achieve. Like I can say as much the component we are exhibiting in this case was really one of the components where we had the unique challenge of we needed a relatively high TG, a tough system, but we also needed to have FST compliance and the oil burner test requirements for anybody that is familiar with the engine nacelle areas. And that's one of the systems that we have developed that, well, you don't need any additional flame retardants, you don't need any additional coatings or layers or etc. for it. So you can now really unlock a much greater potential of what you can achieve within a part, because you don't have to machine a firewall out of titanium anymore, or you don't have to add stainless steel liners or anything to it. You just have the full design freedom of composites, and you have the assurance you can just go with that and you'll pass the test.
Okay, so we have Simonetta also in our chat today. Thanks for the very interesting presentations. She says, hope to meet you at JEC. Of course, we will meet at JEC. Yeah, Simonetta, she's quite active on LinkedIn. I see her engaging in many places, and I would be curious to meet you also in person. And I'm sure she will stop by your booth as well, so you can show her your great solutions. So for everyone who have tuned in at a later stage to this brilliant LinkedIn live show, Max has shown us how you can organize your product development in in a way that is full of incremental steps, but can be cost-wise sensitively made and scale up in a very fast pace. Of course, we have investments here, and that has been shown by this nice graphic, which goes below the zero and then goes exponentially, nearly exponentially up. And this is how composites work. You have this first investment into the R&D, into your tooling, and with RAMPF you have now solutions in the resin systems that are very fast to apply. Very fast solutions can be created by them. You have toolings that are cost sensitive, lower cost compared to other toolings. Just contrast yourself. Contact Max after this show, and if you find this show after you've tuned in interesting, this is now available as a replay just after I stop this stream. I recommend it fully to you. Go back, look at it. In about minute 15 to 20 of this LinkedIn live stream, we had also Eric, a special and surprise guest, Eric Pierjean, the CEO of JEC Global. He was also, telling us about the news of JEC World that is coming up in 2 weeks' time. We will meet you all there. Thank you once again, Max, for your, opening your virtual doors for our LinkedIn community, Composites community. I'm very eager to have also Alexander Egge in one of my future live shows, so we can dive also deeper into the tooling topics.
Yeah. He is one of the brains behind the resin and has a lot more knowledge on the tooling side than I do. I just apply the stuff. So.
Okay.
Thank you very much for the attention, and come by, stop by at the booth at JEC. If you can't make it there, reach out to us, and we'll work things out.
Okay, so the community has engaged also with the LinkedIn Live. We will be saying now goodbye and see you soon. Bye bye.
Thank you. Bye.